Hello, this is Ron England, and this is the EGN3613 Engineering Economics Problem Solving Session for Module number 2. Oh, sorry. Yep, Module number 3. Module number 3, which covers Module 2 and Module 3. This is just going to be some samples of some problems that we're going to show how to solve. Might be tremendously useful to you when you're actually trying to take the different quizzes and calculation assignments. So I'm just going to solve 5 problems, show you some different methodology. These might look familiar if you're trying to solve the homeworks, and I'm going to show you how to do it. All right, first, manufacturing company would like to borrow $250,000 to add a new production line in their facility. We're looking at a simple interest loan, 6% over 3 years. How much is it got to pay back in year 3? This one's relatively straightforward. To actually calculate the interest paid, the interest that you would owe, it's simply the loan amount times the interest rate times the number of years. That's a simple interest loan. That'd be $45,000, which you add to the original $250,000 that the loan is. So you will need to pay back $295,000 in year 3. Not likely that you're going to get a simple interest loan for 3 years. So, what about compounded? If we do annual compounding, we compound the interest. Let's look at this one then. All right, now, this is the case where you're going to actually, and notice, I am going to use the shortcut notation all the time. Okay, a lot. What we want to do is calculate the future value given the present value of $250,000. Shortcut notation is the actual calculation, future over present, interest rate, number of years. That equation is 1 plus the interest rate to the power of the number of years. It's a pretty straightforward equation, and it is one of the ones that I tell you you should memorize. All right, multiply that number times the total loan amount, and you're going to get a future value of the original present value of $250,000 to be $297,754. If you subtract that from the original loan amount, okay, the original that minus the original loan amount, you'll actually get the amount of interest paid if you needed to know that. And I think it actually just asks what would be the amount of money to pay back in 3 years if the interest rate is compounded. And there you go, $297,754 for this specific equation. More important, how you calculate it. All right, let's go on to another question. I think this one's pretty straightforward. Notice the annotation goes with the equation. And the equation, in this case, 1 plus the interest rate, which is actually right there in B5, okay, up arrow, B6, which is the number of years, times the, in this case, multiplied by the original loan amount, and that gave that to you. All right, let's do another one. New college graduate has a job at the Aerospace Company, borrow $25,000 to buy a new car, rent an apartment, furnish your apartment. She's going to repay the entire principal plus 7% interest per year after 3 years. Okay, compound interest, pretty straightforward. This will be your F over P. Again, the equation I told you that you should memorize. All right, so it's going to be the original loan amount plus 1 plus the interest rate to the number of years, $30,626.08. Pretty straightforward. Bow. Let's try another one. How much do you need to deposit in your savings account today at 10% interest to be able to calculate $8,574.35 in 8 years? Okay, so it says use Excel. I always use Excel. Pretty straightforward. All right, so if your future value, they're telling you how much you're going to collect in 8 years, is $8,574.35. This is going to be a calculation of present value over the future value at that interest rate number of years. All right, well, that's, again, not tremendously difficult. Okay, you can either divide by 1 plus the interest rate to the number of years, or you can multiply by 1 plus the interest rate to the negative number of years. It's the same thing mathematically, and you're going to come out with $4,000. Okay, and you can actually do a calculation on a year-by-year basis how much money is going to be in that account. Okay, and at year 8, well, no surprise, you end up with the same thing. So, no problem there. Let's move on to the next question. Oops, let's slide over a touch. If you deposited $5,000 in your savings account 3 years ago and you will collect them now as $5,995.08, what was the interest rate in your account? Well, this one is a little bit different because you're given what F over P is, okay? Now, that value, you want to be $5,955.08. Well, in my spreadsheet, it shows that. But why? How does it show that? Well, it shows that because I did goal seek. So I'm going to go to data. Okay, in the data, you're going to see a what if analysis, and you're going to see goal seek. Okay, you want to set this cell right here, to be equal to 5995.08 by changing the value of the interest rate. And if you do that, it's going to just end up at the same place. I could have started with 0 and done exactly the same thing. What if? Goal seek. We want to set this cell equal to 5995.08 by changing the interest rate. Oops. Oh, hang on. By changing the value there. Ooh, hang on. I got a few things there. I got 2 cells in there. I don't want 2 cells in there. I want 1 cell. Okay, I want to set cell, this one, to be that value by changing that cell. There we go. Now we got it. And whoops, reference isn't valid. Hang on. Let's go back again here. So, oh, I totally got rid of my equation. Oh, no. Well, what will we do? Well, you know what? Let's write that equation in. Okay, present over future. All right, it's going to be equal to that number times 1 plus the interest rate, which is this number, which, by the way, is the one that I actually want to set to 0. Up arrow, that number. Okay, well, we went back to 59.90. Okay, went back to that, but now let's go back and set this to 0. Okay, now it's zeroed out. I want to make this number to be equal to this number by changing this number. So we go back to what if, and you get to see we can have one more last time. We want to set the cell. We want to set this cell to be 5995.08 by changing the interest rate cell. Whoops. Boosh. And there we go. Whew. Get out of that one. Okay, using the same interest rate that you calculated if you left your money in the bank, how long would it take for the initial deposit to double? All right. Well, we got another data seek. So this is now the interest rate. Okay, this is now the variable, and we want this target value by you have to have a calculation cell. So the calculation cell is going to be, now if I change this to 0, that number is going to go back to 5,000 because that's what we started with. So if I go to the what if analysis and I do a goal seek again, now I want this cell right there to be equal to 10,000. I want to double my money. Oops, did I make it 100,000? 10,000. And I want to do it by changing that cell. And away it goes, and whoop, there it does. All right, Using the tables provided in the back of the book, find the discount factor of an institution that provides 11% compound interest after 6. Okay, I'm blasted through this one because the question is, which of the institutions would you prefer? The one that's giving you 6.24% interest, or in C, the one that is giving you 11% interest? I don't even need to do any calculations. It would be the one that's giving you 11. Why? Because that's better rate of return than 6.24. All right, last one that I'm going to do for this calculation assignment. Find the future amount of money in an account that earns 8% interest if you're depositing $2,400 annually for 4 years. Well, there's actually 2 ways I can do it. If you use the equation that you know, and let's say, now we're going to go backwards because, we can do it forwards, it doesn't really matter. But what I want to do is I want to find the future value of these deposits. So I deposit $2,400, I calculate the future value, okay? Year 0 is, in this case, the final year. So the $2,400 deposited in year 0 is going to be worth $2,400. 1 year in the past, that money is going to be worth $2,592. That actually is the interest I'm going to get on that money that I deposited. Okay, that money is now going to be worth this much in the final year. Go back 1 more year, that money is going to be worth this much. That's how much interest I'll earn on the $2,400 I deposited in this year, and that's how much I'm going to earn in the money that I deposited in this year. However, there actually is an equation for that. That's the F over A. Okay, A standing for annuity. Okay, and that has an equation for it right here. 1 plus I to the n minus 1 over I. Okay, and that will give you a number. Then you multiply times the A to get the F. But note, same number. Why? Because it's the same calculation. Okay, all I did was just take the previous all 4 years, figured out what the future value of the money from that year was in the final year, and added them all up, or I could use this equation. Either one is fine. Either one will give you the same answer. There you go. You've now seen it, and you've seen this with actual numbers. Here's what I recommend. I highly recommend create a spreadsheet that does these calculations, but don't worry about what problem you're actually solving. Okay? Leave it generic so that you can change these numbers. For example, what would this be at 9% interest rate? Well, if I put a 9 in there, voila, everything just changed. So you know what? If I actually had to calculate this exact problem with different numbers, I could do it. Now, though, if I change the n to 8, that's going to work over here, but it's not going to work over here because I'd have to create 4 more rows. Okay, that was for demonstration anyway. But voila, you can see I can just change the numbers, see the new answer. You get your spreadsheets to work like mine, then you've got an easy way to solve this. Now, suppose I did actually want to see this, okay, for a whole bunch of different years. Suppose I did want to be able to know what it was for this. Well, I could have easily taken this calculation and moved it over to here. Okay. Okay, where would be the place to put it? I could put it over. Oh, you know what? I could put it down here. Well, anyway, what I could do is I could take these rows and I could slide them down. I could take this, I could slide it down to here. Now that goes with that calculation. And then I could just create some rows up further, and I could then calculate at any of those given years what it was. Either way, it can still do it. So in other words, if I wanted to know what it was worth at this point in time, instead of summing up all 4 of these, I could say equal to sum of, whoops, slide it over. It's not going to like that because it's not going to like it. It's going to want to be F. Yeah. Oh, I hate that. I don't like my calculation. It's not G9. It's F9. And that would be what it would be if that n was 3. How do I know that? Change n to 3. Whoops. Did I sum them wrong? Oh, you know what? Because I have to actually change the values here too to go with that. It's still doable. You can still actually do this and actually just calculate for each of the individual years. Not a problem. All right. I think I've given you some demonstration of how to do some little spreadsheeting and enough to get you going on at least the first quiz. You're going to get one of these calculation lectures with pretty much most of the modules because I wanted you to know how to do calculations associated with those modules. All right, that's it. EGN 3613, Module 3, Example Problems.